Good morning, students. In last video, we studied that when a current is passed through a straight wire or a coil, magnetic field is produced around it. Its reverse is also possible. That is, by using the magnetism, by using the magnet, we can also produce the electric current. And this is called the electromagnetic induction. So, electromagnetic induction means the production of electricity by using the magnet is called the electromagnetic induction. The first scientist who observed that the electricity can be produced by using the magnet is the name is Michael Faraday. Michael Faraday. He was the first scientist who observed that by using magnet we can also produce the electric current. He used a magnet such like a bar magnet and a coil, and by using these apparatus, we can say magnet and the coil, he produced the current in the coil. And sorry, not the battery, here should be a galvanometer. What is galvanometer? I will explain you. So Michael Faraday was the first scientist who observed that by using the magnet we can also produce the electricity. This process, that is the production of electricity by using the magnet, is called the electromagnetic induction. So first of all, we will write the definition of electromagnetic induction. Electromagnetic induction. So we will write the definition. The production of electricity. We are producing the electricity by using the magnet. This production is called the electromagnetic induction. The production of electricity from magnetism is called electromagnetic induction. So this is the electromagnetic induction, the production of electricity by using the magnet. And this type of current which is produced by using the magnet is called the induced current. So you will also write the definition of induced current. You have to write it. Induced current. What is induced current? The current produced by moving coil in a magnetic field. Don't worry, I will explain you what is this, what I am writing here. Magnetic field is called induced current. Why I wrote this term, the moving coil, I am explaining you. According to the Faraday experiment, he took a magnet. This is the N pole and this is the S pole of the magnet, and he make a coil by using an insulated copper wire, turn around a cardboard, and he used a galvanometer. First of all, we should know what is the galvanometer. Actually, galvanometer is a device. This is the device which is a pointer which point towards a zero. Here it is 0. When current is produced in any circuit, suppose it is connected to the circuit, or if a current is produced here in this circuit, this galvanometer show deflection. Suppose the current is produced in this direction, this will show the deflection in any side, like this one or this one. Or if the current is reversed, its deflection is also reversed. It means the galvanometer is an instrument. This is an instrument that can detect the presence of the current in the circuit. It can be used only to find the presence of the current. It do not measure the current, but it is only used for finding current is here in the circuit or not. So galvanometer is an instrument. You can write about the galvanometer. Galvanometer, it is an instrument that can detect the presence of the current in the circuit. So it is only used to detect the presence of the current in the circuit. Its pointer is only towards the 0, or it can reflect here or it can be reflected here according to the direction of the current. Okay, so Faraday used the strong magnet. He used a coil, and this coil is connected with the galvanometer. Now if he bring this coil near to the he bring this magnet near to the coil. Suppose he bring the north pole of the magnet near to the coil. I'm representing it by the side A and B. He found that by moving this north pole towards the coil, it deflect like here, deflect in this direction. Suppose it reflected in the left side. Okay, this deflection, the galvanometer show that the current is induced in the coil. Or if he stop the movement of the coil or the magnet. देखो उसने मूव अभी खाली मैग्नेट को कराया है, कॉइल भी मूव कर सकती है. तो कॉइल स्टेशनरी है, अभी मैग्नेट मूव कर रही है. तो जब उसने मैग्नेट को मूव किया तो उसने देखा कि डिफ्लेक्शन आता है गैल्वेनोमीटर में. नाउ इफ वी ब्रिंग दिस कॉइल away from the not this coil, this is the magnet, and he bring this magnet away from the coil. He found that when he brought this magnet away from the coil, he found that the direction of deflection in the galvanometer is also reversed. It means the direction of current induced in the coil is reversed. Suppose it was moving in this direction first time, now the direction of the current in the coil will be in this direction, opposite to the first one. Same as if he brought this magnet, suppose the S pole. Suppose he brought S pole of the magnet near the coil. He found that the direction of current induced in the coil is reversed to the first one from the first case. First case, if the direction of current is this one, now when he bring south pole near the coil, its direction is in opposite direction. Same as it's vice versa, means if you bring south pole away from this coil, he found that the current produced in the coil is also reversed. Also, if he change the movement of the coil, it means कि if he put the stationary the magnet and he move the coil against this relative motion to this magnet. Now the magnet is stationary and the coil, he moved this coil. When he moved this coil, he find that the current is also induced in it. But what is the main observation he found? That he found that if we don't move anything like the coil or the magnet, he found that if we put stationary this magnet or the coil, current do not induced in it. It means current is not produced in the coil. If he don't move the coil or the magnet, he found that current do not produced in this coil. So it means it is necessary that we should move a coil or the magnet. It means a relative motion of both of them are necessary. या तो इसको मूव कराओ या फिर इसको मूव कराओ. अगर दोनों में से कोई भी मूव नहीं कर रहा है तो करंट इंड्यूस्ड नहीं होता है. तो आप लिख सकते हैं अब इसको कुछ फेराडे के एक्सपेरिमेंट के अकॉर्डिंग. वी कैन राइट सम ऑब्जर्वेशन अकॉर्डिंग टू द फेराडे एक्सपेरिमेंट. दिस इज द Faraday experiment. The observation of the Faraday experiment. First observation, he found that a current is induced. A current is induced in coil when coil moved relative to fixed magnet. if he don't move the magnet, or if he move the coil, he found that the current is induced in the coil. A current is induced in the coil when the coil moved relative to the fixed magnet. It means a relative motion is necessary either of the magnet or of the coil. Second point. Second point, a current is also induced. A current is induced. Current is induced in a fixed coil. Now he is not moving. Yeah, we can say we are not moving the coil now. We are moving the magnet now. So the current is also induced in a fixed coil when magnet is moved relative to fixed coil. It means we don't move the coil, but now we are moving the magnet. So by moving any of these, like the magnet or the coil, the current is induced to the fixed. Now here is a fixed magnet, fixed coil. Okay. Now the third point. He found that no current is produced, no current is induced in the coil if there is no relative motion between these two. So we will write here, no current is induced in a coil when the coil or magnet both are stationary. Both are stationary. Both are stationary. Related to one another. Relative to one another. If there is no motion in the coil or in the magnet, the current do not induced, current do not produced. When the direction of motion, if we reverse the direction of the motion, like in first case we are moving this north pole towards the coil, the current suppose the current is induced in this direction, or if we move away this pole from the coil, we find that the direction of current is also reversed. So we can say, when direction of motion of coil, when direction of motion of coil is reversed, the direction of current induced. Induced current means the current which is produced by this magnet. The current induced in coil gets reversed. Okay. Now the next point. How this induced current can be increased? How can we increase the induced current? Okay, sorry. You are not able to see what I am writing here. Sorry, really sorry for that. तो मैं आपको बता रही थी, magnitude of the current which is produced in the coil can be increased. What are the different we can say method by which we can increase the magnitude of the induced current. First, by winding the coil on the soft iron core. If we use the soft iron core for winding this copper wire, we can increase the induced current. Second, by increasing the number of turns. By increasing the number of turns, we can also increase the induced current in it. Third one, by the strength of the magnet. If we use a strong magnet like the electromagnet, the induced current will be improved, will be increased. And by increasing the speed of the movement. आप इसको ला रहे हैं, आपको बहुत तेज़ी से लाते हैं, तो इंड्यूस्ड करंट ज़्यादा होता है. धीरे लाते हैं, कम होता है. या इसको दूर लेके जाते हैं, जितना ज़्यादा स्पीड आप चेंज करते हैं, उतना ज़्यादा ही करंट भी इंड्यूस्ड होता है. तो नाउ द फर्स्ट पॉइंट यू कैन राइट हियर, magnitude of current induced can be increased first by winding the coil on, sorry one लिख दिया, on soft iron core. Okay, now the second one, by increasing the number of turns, in coil. By increasing these turns, we can increase the induced current produced in the coil. And next you can write here the third point for increasing the induced current, by increasing the strength of the magnet. By increasing the strength of magnet. And fourth point is by increasing the speed of rotation of coil. In this lecture we understand how Michael Faraday do some experiment in which he found that by using the magnet electricity can be induced, and this type of electricity which is induced by using the magnet is called the induced current. Okay, now in next lecture we will study about how can we find the direction of the induced current by this magnet. Okay, till then, bye.